Let's get started. All right, let's see. All right, in our last lecture, we discussed how to integrate a database, right? We had been using our server, right, to manipulate, data structures, and the server was remembering all our changes, and just plain old variables, right? That as long as the server was running, right, it would remember all our changes, right? And before that, we were doing the changes on local variables in the browser, right? And certainly we had a problem in the browser when you refresh the browser, we would lose all those changes. So definitely was not a permanent solution, right? When we moved it over to the server, it was slightly better since it would survive changes, it would survive uh, across multiple requests, or even refreshing the browser, since as long as the server was running, we would be able to maintain the state of those variables. But finally, we decided on a permanent storage solution, and we're using a MongoDB as our permanent storage solution. So today we're going to go further, right? We covered the basic skill sets, right, of connecting to the database, declaring schemas and models, and doing some basic inserts, updates, deletes, right, and integrated with our application, our Node application. So today we're going to go a little further. We're going to talk about several options on how to model different types of relationships, such as one-to-many, many-to-many relationships. And we're going to do that using our Kambaz application as our use case, right? We're going to apply these skills, right? But as we work toward completing our Kambaz application that we've been working throughout the semester. Okay, so that's the intent for today's lecture. Okay, yeah, so today we're going to be discussing how we integrate the Kambaz data structures and user interface, right, with our permanent storage solution, which is a MongoDB. This is the architecture of our application, right? We focus the first half of the semester to building the client side of a client server application. And the second half we are dedicating to exploring, learning about building a server plus the database, the backend side, the server side of our server or client server application. I've been focusing the last couple of lectures on creating schemas and models using the Mongoose library that allows us to interface or integrate with the database. Now let's talk about modeling courses. What we mean by modeling is the choices we make, right, when we are looking at the data structures and how do we organize it, right? What is the structure of the data, how is it related to one another, and identifying the various pieces of information that we're going to store, and how can we collect them together, group them together, and then choose to store them in one table or one collection or another. And so we've been focusing in our last lecture how to model users, right? We discussed about the schema, right, and the DAO and the model, and how to integrate with the database, right, to be able to do all various CRUD operations on user, and create, read, update, and delete users in our database. And that user that we created, right, is just the beginning, right? There's quite a few other data structures, right, that we need to consider, such as courses, modules, and lessons. And this is basically the data, the data design, the data model for the various data sets that we're working with, where we're working with courses, modules, lessons, right? And these are some of the fields that of interest, and along with how each of these instances of users and courses are related to one another. We know that between a user and a course, there's a many-to-many relationship, right? Many users are enrolled in many courses. Also, there's a one-to-many relationship between a course and a module. For each course, there are several modules. And there's also a one-to-many relationship between one module and several lessons. So let's tackle the courses, right? We tackled users in the last lecture, Let's move on to courses, right, on their own, and we can then focus on how we can relate, users and courses, as well as relating courses and modules. For the, as we saw in when we were building the user models and schemas and whatnot, right? It kind of follows a pattern, right? We're going to apply the same pattern here in the courses, right? The general architecture is that we have the routes that are receiving HTTP requests from the client, right? Sending posts and puts and gets and deletes, right? Through an AJAX library, right? We chose Axios. And those routes invoke functions, right? Execute functions in our course router that then they parse out the HTTP body, the HTTP URL, with parameters encoded in the path name, in the path, and also encoded as the query strings, right? And then the courses route, kind of implements the interface between the rest of the world, right? The clients, right? The browsers, or anything that can send HTTP requests. We are intercepted those requests by these routes, and then they delegate the actual work, right, to some DAO. The DAO is then responsible for all the various data access, all the data access and manipulation, right, of that with the data layer, right, and it uses the models, Mongoose models in our case, right, that provides the low-level API or interaction to actually send, manipulate the data in the database, right. The models typically they use a schema, right, that declares the structure of whatever it is that you're manipulating. In our case, it's the courses schema, and the courses model, make sure that the data that is coming from the DAO, from the routes, right, whenever it's going to insert or update something to data, all those operations are validated against the schema, right, making sure that the various properties have the correct names, that they are the correct data type, and so on, right? And then it does the CRUD operations onto the MongoDB. So today, we're going to spend quite a while, right, implementing these routes and DAOs and models and schemas, right, that are related to courses. So first, let's focus on implementing the schema, right? Let's take a look at this right here, the course schema. Okay. So as we saw when we worked on users, right, we built schemas using the mongoose.schema property, right? That allows us to declare the form, right, the structure of courses, right? And so we have primary keys, we have the name of the course, the number of the course, credits, description, and so on. And we're also describing the fact that this is going to be stored in a collection called courses. So let's do that, right? Let's create the schema file in our application, in our Node.js application. So here under courses, let's create a schema file, and let's declare it right here. There we go. So we have the schema for the courses. Next, let's declare the model. Again, the model is the Mongoose repository of all the low-level functions that is going to allow us to interact with the database, right? And what it does is that it takes as argument the schema of what it is that you're trying to interact. So for instance, we import the schema, right? And then we create a new model, based on that schema. And what the model does, right, is that it has all the functions, right, that allows us to interact with the database, right? It has finder functions that allow us to retrieve multiple records or one record, or retrieve them by primary key. It allows us to delete records, right? Either multiple records one at a time. If we provide the criteria for the records that we want to remove, or we can remove just one record, right? We can also update, either many records or update a single record, or we can insert or create, you know, new instances, right, that are inserted into the database. So it provides all the low-level create, read, update, and delete functions to interact with the database. And all those operations, right, are validated against the schema, making sure that the results of those operations match this structure here, right? That certain things should be numbers, strings, right, dates, and whatnot. Okay. Now, we also specify a unique name for the model. Right now, it doesn't matter. We just need to know that this string here needs to be a unique string, right, across a particular instance of the Mongoose connection. So if you're connected, if there's a connection, right, and we're using that one connection, there can only be one model called course model, right? So it has to be unique. Right now, it doesn't matter, but later on, when we start relating when we start relating courses with users, like for instance to implement enrollments, then this name will be relevant. Okay. And the other meaning for this name that is might be of interest is that here, when we name the collection, here we're saying that these courses are going to be stored in a collection called courses, right? So that means that if you go to the database, right, there is indeed a collection called courses. So, all inserts, updates, deletes are going to go against these courses. But, right, if you don't name the collection of your choice, like we did here, if you don't configure that, by default, the name of the collection is based on this name that you gave it here. Okay, so in our case, we are specifying the name of the collection, so it'll go to that name that we specify, not the name of the name of the model here. Okay. All right. So once we have the model, right, we want to start using the model for implementing the various operations. Okay. So let's take a look at the first operation. One of the most common things to do is to retrieve data that is already there. Okay. So there are a couple of retrieval operations. Here are just two that we're interested in. One of them is for finding all the courses, and the other one is for finding the courses for an enrolled user, right? These are, they are useful, for populating the dashboard, right? The dashboard, either needs to display all the courses so students can enroll in courses that they're not currently enrolled, so they'll be able to see all of them, including the ones that they are already enrolled and the ones that they're not enrolled. And then they'll also need to find the ones that belong to them, the ones that they are enrolled, right? That would be the default thing to do, is to display the courses that I'm enrolled, not all of them. And so here we're going to implement that in our DAO, in our course DAO, and now they're going to use these functions are going to use the find method in the model. Remember, the model provides all these functions: find many, find one, find by ID, all these finder methods, and they're all defined in terms of the schema. The DAO is going to basically use the model's find function, right, to retrieve either all the courses or the courses that we are enrolled in. Now, even though the courses are going to be retrieved from the database, right, using the model, we still have to work with the enrollments. Remember that the enrollments is what tells us which courses we are enrolled in, right? So that needs to be put in the database, but we don't have that yet, right? So this is still the enrollments that comes from our fake, database, quote unquote database, that is basically that big object, full of a whole bunch of arrays. So we're still going to be using the enrollments. We'll come back to that a little later. We're still going to have to rely on this, when we implement the find courses for enrolled users, right? Meanwhile, find all courses is trivial. It's just going to retrieve all the courses, from the database, and it's going to be invoked from the route here. Okay. Now, when I say that it retrieves all the courses, obviously our implementation is simple. It retrieves, indeed, it retrieves all the courses. Now, this is a little bit not very realistic, right? That you would actually implement retrieving all the records. I mean, these records, it could be hundreds or even thousands of records. Of course, you wouldn't realistically try to retrieve all 1,000 records. Instead, you would probably implement it in such a way that you would only return maybe a couple of dozen or maybe at most 100, right? And then we would provide mechanisms to paginate through all those courses, perhaps 100 at a time, where you can specify how many you want, right? And then you can offset and continue consuming 100 at a time courses. That's called pagination. So there it is. So here's the implementation for finding all the courses in the DAO. It used to be that we return the database course, but instead we're going to be using the model instead, right? And so we can take a look at that. The current implementation for the DAO for finding all courses is just db.courses. That's the database, right, that we are receiving here as a reference. So instead, right, we are going to import the model. So we're going to import model from models. I think it's in the same directory. Yep. So in here, instead of returning DB courses, we're going to return model dot find. There we go. Okay. Now, because these functions, right, are indeed connecting to the database using the database connection that we opened up in the root server file, right? Because that connection is remote, right? Meaning it's going to go through a network access, presumably with a database that might be running, halfway across the world, right? Since that connection is a little risky, this communication is asynchronous, right? So that means that we have to refactor all our routes, right, to also be asynchronous, right? So by tagging them as async and then using the await keyword, right, whenever we access the DAO, all these functions find all courses. That's this function here. This model.find doesn't actually return the data right away. Instead, what it does is that it returns what is called a promise that in the future you will receive the response, right, asynchronously. So we need to tag that as async await, right, so that at some point in the not too distant future, hopefully, right, we're going to get a callback, right, to interrupt us, right, that returns this data back, right, and then we can assign it locally, and then just respond it back, right, to the client. So let's make that change in the route, right? We have here find all courses. It's using DAO. We'll need to tag it as async and await, right? And then this should work just as before, right? We can try it out. Okay, so let's do nodemon index, create a new. Here we say localhost 4000, right? And then we can say API courses, and let's put this maybe over here. Let's try it again. There we go. Here are our courses. And this indeed should be the courses that we have in our database. Here are the courses. For instance, we have rocket propulsion. Right here we have rocket propulsion. Right, just to make sure. Right, if I make a change in the database and say maybe rocket propulsion 101, and we do an update. Okay, we update it here. If we go back here and refresh, we see that indeed the change has taken. So yes, indeed, we are looking at the courses that are stored in the database. Okay. Another common request, right, that the dashboard needs is to be able to retrieve courses for which we are enrolled. And that is the default set of courses that a user sees whenever they log in, right? And for that implementation, we're going to be using, again, the find method, but we're going to filter those courses by the enrollments. Now, typically you would do that filtering, you would do that in the database, right? Or within a query. Here, because enrollments doesn't yet exist in the database, right? We don't have a schema or model or anything like that. We're still relying on the arrays that are declared in our, quote unquote database, which is just a whole bunch of arrays within a big object. So yes, we're going to retrieve the courses from the database, but we're going to filter them through the enrollments. Okay, and that's going to be accessed right from the route, right, with a similar function. Again, we're going to have to remember to use async await. Right? Okay, so here's the current implementation that we have for finding the courses for enrolled users. Right, it used to be that the courses were retrieved from our fake database, right, just an object with arrays. But instead, we're going to retrieve the courses from the database using the same Mongo.find. Okay, so in our database, in our DAO, and find courses for enrolled users, right? We're not going to retrieve the courses anymore from here. Instead, we're going to do const courses equal model dot find, right? For this, we'll need to label this async, right? And await. So once we have the courses, then we can filter them. Again, we are still using the enrollments, right, from our, quote unquote DB. It's just a big array. And then a little later, we'll revisit this, right, so that we no longer use these enrollments anymore, right? So we'll be able to remove our dependent on this fake database, right? We'll use the DAO that is connected to the database that deals explicitly with enrollments. But for now, we basically, this is a join, right? We are joining the enrollments with users with courses, basically, right? And so that is best done at the database. Okay. So yeah, so we have that, and then when it returns this returns the enrolled courses, because this is async, right? The route also needs to be async await, right? So here is the find course for enrolled users, right? We need to tag this as async, right? And any access to the DAO needs to be await. Okay. There's no way to test this using just a plain browser. We'll need to actually log in and check whether this works or not. Right, so we can try that out. Maybe we'll open up a local host 3000. We're probably going to start the React app. Okay, we just started the server, and so let's try to navigate there. Let's see, localhost 3000. There we go. Let's sign in. And indeed, I believe these are Ada's 3 courses. Okay. All right. All right. Yeah. So let's see. Yeah. So we've added our async await, and we have confirmed that Ada does have those 3 courses. All right. So let's talk about inserting courses into the database. So for that, we're going to be using the model's create function, which basically inserts a new record into the database. Right? So for that, we're going to use the create course that we already have implemented in the DAO. The prior implementation basically pushed new courses into the courses array, right, in our quote unquote database. So instead, we're going to be using model.create. Now, I believe in the prior implementation, we also made sure that when we created a course, we made sure that the current user enrolled into that course. Otherwise, you'd have the case where a faculty would create a course, but they would not see it because they were not enrolled in it. Right. So we are enrolling that user into that course, right after we create it. But again, because enrollments is not yet in the database, right, we're still relying on manipulating just the arrays of enrollments, right? But and we're going to do that from within the DAO that we implemented in a prior assignment, right? Enrolled users in a course, but basically, inserting a new instance of an enrollment, right, into an array. Later on, we'll revisit this, right, where enrollments will be have its own schema, its own model, right, and we'll be manipulating records in the database, but a little later. Okay, so in the create course implementation, it used to be that we instantiated a new object, right, with a new ID, right, and then we just pushed it at the end of the array of courses. Instead, we're going to use model.create. So in the DAO for courses, we have create here. So instead of inserting new instances at the end of an array, we're going to return model.create, new course. And we always have to remember that in the routes, we also have to tag everything with async await. Right? So we should have here a create course. There it is. Right? And so we're going to tag this as async, right? And then the DAO is await. There we go. And we still are using the enrollments DAO. That is, we pass in the ID of the course, right, and the ID of the user, and this one just basically inserts into the array, right? And we'll revisit that in a bit. Yeah, so we added async await. I don't know. Have we removed all in the routes any other use for the DB in the routes? Let's see. Do we use the DB anywhere else? Okay, we still are using it for the enrollments down, so we can't just remove the DB just yet, right? Is the DB used anywhere else? Let's see. Just now for the find. Course, create, delete. Okay, delete is still, okay, we're not using the DB here, right? Okay, all right, so we can't just remove the reference to DB because it's still being used by the enrollments now. Okay, so not quite yet. We can now remove that just yet. Okay, deleting courses. So deleting courses is going to be, now rewritten in terms of the delete one. Okay, that is provided by the Mongoose model. Okay, so we'll rewrite that. Instead of manipulating the array, it's going to delete one. Now, one thing that we didn't implement in our prior assignments was, well, what happens to the enrollments? Right? If you are removing a course, what happens to all the users that are enrolled in that course, right? We should have removed all those enrollments as well, which we didn't. Okay, so a little later we'll come back to that. When we we're going to talk about how to model many-to-many relationships, right? And the enrollments is going to be our many-to-many relationship. So we'll remember to not only delete the course, but then all enrollments that are related to that course. Okay. So right now the implementation is to filter out that particular course, right, from the array of courses, right? But instead, we're going to use the model.delete one, pass the ID of the course and remove it from the database. The enrollments. Okay, so the enrollments are updated, making sure to remove, all enrollments for that course, which is perfect, right? But later on, we'll come back and we'll want to do that in the database as opposed to doing it with the arrays. So delete course in the DAO. So we have here delete course. It's in the DAO. Delete course. There we go. So instead of using the array, right? We're going to comment that out. We're going to use return model delete one course ID. Perfect. Okay. And then in the route that calls that delete, right, we're going to tag this as async and then await. All right. All right, that should work. Okay, how about updating courses? So updating courses, we're going to be using update one, right, where it takes two arguments, the ID of the course that we want to update, and then all the changes, right, whether we change the name of the course or the description of the course and whatnot. Okay. The prior implementation updated the array instance, right, of that specific course in the array of courses. So we're instead going to be notifying the database, right, of whatever new updates we want. First telling it that, what particular course we want to update by telling it the ID of the course, and then using the set operator, right, to kind of merge the current values of the course with any new updates, right? So for instance, the course has quite a few fields, right? It has name, description, right? The starting date, ending date, how many seats. It might have, half a dozen or a dozen different fields. But the course updates might come in with just a subset of those fields, maybe only changing the name of the course, right? Or the starting date. So we want to make sure that we don't replace the course, but instead we merge any updates, right? So that only the fields that have changed, right, are going to be modified, that all the other fields that were there, are not blown away, or we don't lose that, right? So, and that's the purpose of this set operator, that starts with a $ set, right? What it does is that it only changes the fields that have actually changed. So let's do that in the DAO, in the update, right? So instead of doing that, what we're going to do is that we're going to, in the DAO, we'll say update one with the course ID and the course updates, right? And we don't need this anymore. Let me put this at the top like that. Okay. And in the routes, we have to make sure that in the update course, right, here's where we use the DAO, right? We convert this into async, and this is an await. Okay. All right. Okay, so let's talk about one-to-many relationships. So what we mean by one-to-many is that there are instances of pieces of information that might relate to several other pieces of information, right? Where one instance might be related to many other instances, right, of different types, right? For instance, in our example, in our case, right, we have one course that might be related to many modules, right? One course has many modules. And in UML, you capture that idea by declaring classes for each one of the different types of data. Right? So we have a class for courses and another class for modules. And then drawing a line in between them, saying that there's a relationship between the courses and the modules. Right? And then you can add optional cardinality, right, labels here that tell you how many of each participate in that relationship. So this says that one course is related to 0 or more modules. Okay, and that's the case that we have, right? If you in our dashboard, if you navigate to a if you choose a course, then you are displayed with many modules that are related to that course, right? Now, even though we capture this graphically using UML like this conceptually, we have to decide, how is it that we implement that, concretely, how do we implement that using whatever database that we choose? Now, in relational databases, the classical way to implement this, right, is to have having a table that captures all the courses, right, the records of the course where you have the primary keys, the names, the description of the courses, all the instances, each row representing a course, and there's a primary key for each one of those courses. Now, in another table, you would capture the instances of modules, each one with its own primary key and its own fields of name, description, and so on. Okay. Now, to establish the relationship, you would have on the many side, right? Here, the course is on the one side, and modules is on the many side. On the many side, you would have an additional field that was not there originally, right? And that new field, the role of this field is to keep track of the record that this module is related to. So if this record it's a module, right? You would specify the ID of the other record that you are related to. In relational speak, we say that this is a foreign key, that all these are primary keys, right? That each record has a unique identifier that identifies that record uniquely. Instead, foreign keys have values that logically reference, right, or refer to the values of those courses. So the idea would be that we are capturing that this one module is related to that course. If you think of this as a parent-child relationship, the child knows who their parent is, right, with this reference to the parent. Okay. Now, this is different than how you would implement it using classes, right, in an object-oriented programming language, right, like .NET, C#, Java, whatever. Typically, the way you capture that in an object-oriented world, it is the parent, right, that would have an array of children, right? So you would declare in the class course, you would have an array of courses, right? So that the parent would have an array of references to the children. The children typically would not have a reference back to the parent, right? So to this inversion of modeling, or how to implement these relationships, it sometimes is challenging. We often talk about there's an impedance, right? Or there's a chasm, right, between how you capture the same information under one infrastructure, right, in the database, in the relational database, and then how you capture it in another infrastructure, another technology such as object-oriented programming language, right? So this inversion, right, is notable. Now, and in a relational database, this is the only way, right, to actually capture this, right? That it is the children who have a reference to the parent. Now, in a non-relational database, we don't have the limitation, right? The limitation in a relational database is that these fields, in general, these fields are only primitive data types, right? They are strings, numbers, booleans, dates, right? So you can't capture maybe a collection or an array in general. Obviously, modern databases do allow you to have collections of these, right? Arrays. But that limitation does not exist in a non-relational database, right? It is perfectly normal in a non-relational database that a field can be an array. That you could contain, for instance, we could add in courses to implement the one-to-many relationship. We could have an array of module IDs, right, that maintain a reference to all the modules that are related to that course, right? Again, this would be a much more natural mapping to how we think about this in object orientation. It is the parent who has a reference, who has an array of references to its children, right? The child doesn't necessarily need to know who their parent is. Okay? Now, furthermore, right, in non-relational world, we could implement it by just embedding all these records, all the records of the modules in their appropriate course, completely eliminating the need for a separate collection or separate table. Right? In a non-relational database, right? The data structure for the document that maintains the course, the field, that could be a field called module that is an array of modules, right? So all the data that would normally be stored in the modules collection is actually stored in the corresponding instance of the course, right? So that would mean that there would be no possibility of interacting with modules unless it's inside of a course, as opposed to this implementation where modules were listed in a separate collection. It would be totally feasible, right, to list, for instance, all the modules, irrespective of whether they belong to a course or not. Okay. Now, in this case where modules have no meaning outside of the course, then this implementation is actually preferred, right, in non-relational databases, right? It's actually preferable not to have to use a separate collection or separate tables, and instead just embed it inside of its parent. Okay. Now, we'll see a little later that it is not always possible, right, to make this design choice of embedding the data of one collection inside of another, right? For instance, in the example of enrollments, right, we'll see later that actually it would be a bad idea to try to implement this embedding, right? So this is a choice that we're going to go with, right? Embedding modules inside courses. So let's talk about embedded schemas. So embedded schemas is actually the proper preferred way, right? If at all possible, to embed data within other data, right, as opposed to separate collections. So what we're going to do is that to implement our one-to-many relationship, we're going to have a class, right, or a table collection, right, declare an array of modules. Okay, so we're going to create a new type, right, module, and which has its own fields of name, description, and so on the many side. And then on the one side, we're going to declare a new field that is going to keep track of an array of instances of those modules, right? Graphically, you would capture it this way, right? Where you have a schema for the module, which is embedded inside a parent schema for the courses. Right, so the way you implement this is first declare the schema of the child, right? Like we're doing here. So we're gonna have a new schema for the module, right? So let's see, we're gonna copy that, and we're gonna go here in the modules, right? We're gonna have a new schema that. Oops, where is it? Let's copy that schema. Once we declare the schema, notice that we are not declaring what collection is this going to be stored, because we're not going to store it in a separate collection. Instead, right, we have this inner module schema that is going to live inside of a larger course schema like that, right? And the syntax to do that is to first import that other schema and then declare a new field modules, and then which its value is going to be an array of those schemas. Now notice that the syntax here is not to declare a type and then the square brackets at the end. Instead, you define this. The syntax is to define the square brackets around the schema. And so let's do that, right? In the course schema, we're going to import the module schema. There we go. And then here declare modules to be an array of schemas, of module schemas. Now, there's another one-to-many relationship between the modules and the lessons, right? One module actually contains many lessons. Again, these lessons don't exist outside of their modules, right? It's not like you're going to access lessons, right? Like a whole bunch of lessons, without knowing what module they belong to. They only have a meaning inside of the module, just like the modules have only a meaning inside of the course. Right? Now, to implement this, again, we could follow the same approach, right? Defining a separate schema and then declaring that schema as an array of the module schema. But there's a faster, more terse way of doing it, right? It's you can instead of declaring a separate schema, you could declare all inside of the parent schema like this, right? So it is declaring the schema inline as opposed to in a separate file. Now, declaring in a separate file is the proper kosher industry standard, the correct way of doing it. But I did want to point out that you can also do it this way, so that you know of the option, right? The alternative. Although, again, it's preferable to have a separate schema file, right, imported, and then declare it here. But nevertheless, I did want you to know about this option, right? So here, we're going to declare lessons, right, where each lesson has a primary key, has a name, right, and has a description. All right. Okay, so I do have a document ready for us to be able to import, right? That mushes everything together, right? That declares all the courses that we have. So these are all all the courses that we had already, and there's 9 courses. And typically, you would only have these fields in the courses, right? But now we are adding the modules. And what I've done is that I've gone ahead and taken all the modules from the modules array or the modules JSON file and copy them into the modules field, right? These are all the modules. And so, and then also the lessons inside of the modules that are here. So here are the lessons. Right, and here we have the modules with the lessons, right? Okay, so perfect. So I'm gonna download this. And I'm gonna go, let's see, and we'll put it here, fall. And put it here in the database, and there it is. So this is a new file. And what we're gonna do is that we're going to drop the current data that we have there of all the courses that we have in there, right? Because this one is just flat, right? It doesn't contain any of the modules, doesn't contain any of the lessons. So we can remove all the records, right? By clicking there, the trash can, and we'll say that remove. It says it's permanent, right? We can't undo it. That's fine. We're going to remove that. We're going to refresh to see if there's anything there. Perfect. And then we're going to import the new file that we downloaded. Kambaz database. There it is. This is our new file. Let me see. Yeah, there it is. So these the course. We have the modules, the lessons. Perfect. So let's select that and let's import. There it is. Okay. We can just check to see now the courses contain this new field called modules that is an array. It has 3 objects in there, and then each one of them has lessons in there. So yeah, so everything's embedded, right? Each one of these documents it could be fairly long, fairly complex, but this is actually the preferred method, right? That MongoDB prefers, right? To have large documents which you can then select pieces here and there with operations that you can say, well, maybe I only want the name and the description and so on, right? I want to ignore everything else, right? So, and we'll do that a little later. Okay, so we have that. We imported it into our database. Now, in our dashboard, when we fetch these courses, the original implementation actually retrieve the courses and contain just a handful of fields. But now that same implementation for the dashboard is actually going to be very, very verbose, right? It's going to have a lot of information, tons of information that we don't need in the dashboard, right? These courses that we were retrieving from the database were fairly sparse, right? They just contain the name and the description, and that's it, right? But now, if we do this again, right, and we sign in and take a look at the data that's coming back from the server, we say network here, and say Ada 1, 2, 3. So we are retrieving the courses still, but notice that now the courses that are coming back contain all these other fields that we don't really care for, right? Modules and lessons. And, I mean, this is a lot of information that I don't really need. I would prefer that in the dashboard, I would only really need the number, the name, right? The ID, obviously, and the description. That's all I really need in the ID, in the user interface. And we can choose that, right? So for instance, we can modify our finder functions, right, to only choose a subset of the fields, right? So for instance, we don't really care about the modules. Actually, we do care about the description. And so you can list which ones you want, right, by putting the name of the field, right, and then a 1 for yes, I want it, or -1 if you don't want the field that you don't want, right? Notice the find method. Normally, we were using it with no arguments, but here we're passing 2 arguments. The first argument is the pattern match, saying what the criteria is to filter this particular record, and so we're leaving it empty, meaning we want all of it, all the courses, right? There is no criteria. Just give me all the courses, which is the same thing as fine with open close parentheses and no arguments. But because we do need to pass the second argument, right? We also need to pass in the first argument, but we're passing it as an empty object, meaning no criteria, meaning this is like select star from from courses and have no where clause, right? We want all the documents. And so this second argument allows you to choose exactly which fields you want, right? So let's refactor that in the courses DAO, right? In our find all courses, we'll say, okay, well, this find method here, right, with no criteria, we know it's the same thing as doing this, right? There's no criteria, meaning give me all of them. Now, but usually you don't need to provide it, right, because it's the default. But because we need to provide the second argument, right, we do need to provide the first argument. And in this argument, you can list the fields that you want, right? Instead of giving me all the fields, I only want the name and the description. Okay. And we don't want the credits, we don't want the numbers. That's it. Okay. Now, if it's not listed here, then it will not be sent over to the server, right? Only the fields that you're listing here are going to make it into the server. Now you can do the inverse where you say what fields you don't want, right? And you can use a -1. So for instance, if you say minus here, you're saying that I don't want the name and I don't want the description, right? And all the other ones would be there. Okay. All right, so let's talk about that. Now, though the ID is not listed here, by default, the ID will be included in the response, right? Even if you didn't ask for it, right? I mean, you could specifically say that you don't want the ID by saying underscore ID :-1, right? And then it would deliberately remove the ID, right? By default, even if you don't explicitly remove it, it'll include the ID as part of the response. And we also want to include that here in the find courses for enrollment. We'll do the same filter here. There we go. All right. So now let's try that out. We can go back here, refresh, sign in again. And if we look at the response coming from the database, there it is, right? We only have the fields that we need, name and description, and the ID, even though we didn't ask for it. Okay. All right. All right. Let's talk about retrieving modules. So retrieving modules right now is modules are just a field as a part of the course, right? So before when we were retrieving modules, modules belong to a different database, quote unquote DB object, right? There was an array of modules, and we were basically doing a join here, right? We were joining the modules ID, a foreign key with the ID of the course. We were joining the course and the modules, basically, right? And filtering out the modules for that particular course, right? Because modules live in a separate data structure. This time around, it doesn't, right? It just is part of the course, meaning that if you retrieve the course, that course will have the modules inside, so you can retrieve that. Now, this find by ID, retrieves the module by its ID, right? Including the lessons, including everything, all the fields. You can specify which, again, here you can filter and say, which fields you want. Here's going to return all the fields because we're not filtering, we're not projecting. Yeah, that operation here of explicitly telling, configuring which fields you actually want is called projection, right? To project. Here we're not projecting. That means we are, just receiving all the fields, of which modules is one of them, right? And you was just returning the modules. So let's do that. So define modules for course in the modules DAO. So let's see, in the modules DAO, we have find modules for course, right? Instead of using this implementation that uses the array of modules, right? We no longer have that. And we're going to import the course model, right? And then here we're going to retrieve the course. This will have to be async. And this will be await find course by ID, and then we'll just return the modules. Right? Whenever we are talking to the model, we need to put in await in async. Okay. All right. So once we have that, the route for finding modules for course is this one right here. There it is, right? We're going to also put this async await, async, and then an await. There we go. So let's try that out in the server user interface. Let's go back to the account. Let's log in again, Ada123. And if we click on propulsion, yeah, it retrieved the same exact modules as before, right? Just to make sure that we are indeed hitting the server, the database, right, as opposed to the array, let's change just one of the names of these modules. So history of rocketry. Let's see here, module. So rocket propulsion, introduction to rocket propulsion. So it's this one, right? Introduction to rocket propulsion. So let's change this to be something else. So 101, and then update. Right. Let's go back. Let's clear this, hit it, and there it is, 101. Right. So whatever changes we make in the database, we are indeed getting those changes from the database. Okay. Right. How about creating modules? So it used to be that creating modules was of inserting or pushing, right, the module object, right, into the array of modules, right, and each module was responsible for maintaining or knowing who the parent course was, right. Now, instead, the course actually belongs inside of the module, inside of the course, right? So there is no point of the module referencing the course anymore, right? Instead, it's just the module and the primary key. It doesn't have anymore a reference to its parent, okay? And instead, this new module would need to be added to the array in the database, right? Remember, each database course has an array of modules. So we would need to have to push into this array of modules in the database. And Mongoose has an API for that, right? You can use the update function, right, in the model, identify which record you are manipulating. And then in there, there's an array called modules that you want to push a new item into that array, and the new item would be new module. It would appear right at the end of this array. So it would be just pushed at the end of this array in the database, right? And then that would be saved in the database. Okay. All right, so let's do that. Let's copy this as the new implementation for the create module, right? In the modules DAO. So in the modules DAO, create new module, we have this implementation. There we go. And so we're pushing into the array in the module. Okay. Now in the uh, route, okay. And again, we're going to have to do the async await everywhere, right? And now our create module takes in new arguments, okay? Because it used to be right that each module had a reference to its parent course, but no more. That is no longer the case. Right? It's that we first have to identify the course instance in the database, right, and then push the new instance module into that array. Right? So it's no longer the module who has a reference to the parent. Okay. So yeah, so let's make these modifications in the create module for course in the routes. So create module for routes, right? We no longer are going to do this. We're going to pass in the course as an argument, and we're going to convert this into async and then await here. Okay. So let's do that. Let's try it out. Let's log in, sign in. And so let's create a new module. So we'll say, let's go into the here and say new module, module 101. We'll say create module. And it looks like our server didn't like that. So let's say, take a look at the server, what it has to say. Says cannot specify, okay, no. Model is not defined. Kambaz module DAO. Did I misspell it? Let's see. Oh, I called it module. It's a course module. I believe that's going to be the same problem throughout my examples. Okay, let's try it out again. Have to log in again. So to add module 101, add. Okay, so it went out. This is the instance that went out, and the response, with the ID has been added, presumably. let's take a look here. So it's being added to this course. Let's refresh. And indeed, we have now 4 items. The last one being the module 101 that we just created. Okay. Right. How about deleting modules? So the prior implementation was to calculate, right, to filter out, right, that particular module by its primary key out of the modules array. Instead, what we're going to do is that we're going to, just like we use push to insert, right, the new module into the array, we can use instead pull. Pull is the opposite of push, right? It removes. It's kind of like splice. It splices out, an item from an array, right? So let's grab that and let's re-implement the delete module, right, in the modules DAO. So in the modules DAO, the new delete, right, is implemented as follows. Now the updates, all the updates and delete functions, they return a status. Unlike the, for instance, when we create a new course, right, or when we retrieve a course, they return arrays or instances of objects, right? Of whatever it is that you're manipulating or you're creating new course. It gives you a reference to the course, the reference of modules, actual. But instead, whenever you remove, and as we'll see in a minute, whenever you update, what the database returns is a status telling you whether the operation was successful and how many records were updated or affected, right? And so that's metadata that perhaps it's useful for the user interface, right? So it's a good idea to respond, right, with the status, send it back to the user interface if they want to display some alert box or some info in the user interface. So once we do the update, right, we're going to factor the delete module function, right? And we'll do a sync await, certainly. But in addition to that, right, the prior implementation, because the modules existed in their own collection, they existed outside of the courses, there was no need for the course ID. There was no need to know what course it belonged to. But now we do. We do need the course because we first have to identify the course and then pull the module by primary key, out of the array of modules. So now, right, our new version needs the course ID, which we were not using before. So we'll need to refactor our implementation so that we do encode the course ID as part of the URL, right? And we pass it down to the delete module function, right? So let's refactor this, our delete module in the route. So in the route, the delete module, there it is. Oops. Wait a minute, I copied too much. So the delete, there it is. And then the delete route, this one right here. So the change here is that we are now passing the course ID, which we're going to have to parse out from the params, and we're going to pass in the DAO. Oh no, this is the modules DAO. So we'll need to import the modules DAO. Modules DAO from. Oh wait, no, we do have it. Oh, we do have modules DAO. Oh wait, what? Modules DAO. Wait, modules DAO. No, we do have it. Oh, why do I need it? No. DAO. It is DAO. I don't know why the AI was insisting that it was modules DAO. It is the DAO, right, for the modules. Okay, yeah. So we're also going to have to refactor the user interface. The user interface before which again was just passing the ID of the module that was being removed. And this was fine when the modules existed outside of the courses, right? But now because they exist inside of the courses, right, we are going to have to pass in the ID of the course as part of the URL, okay? So in the delete module here in the client, right, then we have the client here. And we have a delete module. We'll also need here the course ID, the string. And we'll use the course API, course ID, modules, module ID, right? Course API, course ID, modules, module ID. All right. And wherever we were calling this, right, from the user interface, right, we had an arm remove module event handler that was only passing the ID of the module, but now we do have to pass the course ID as well. And so that, I believe, is in the module page, right? So here's modules page. We have an on, no, not that one. ID modules page, there it is. We have an on remove, there it is, right? It's expecting the course, which we're not passing it. We're only passing the ID of the module. So we do have the CID that we're passing from the params. Let's pass that down here. So CID, there we go, like that. And as a string, right? A string. So yeah, so now we should be able to remove a module. Let's see if we go back and log in again. Oops, server crashed. Uh-oh. Module down, routes, and module down. Oh. Module down here, right? Okay, let's run it again, right? Okay, let's try it again. Let's log in. Okay, let's go here. And we had created this module first. Let's remove it. So it's removed. Let's make sure that it is removed from the database. So let's refresh this. There were 4 modules first. Let's refresh, and indeed it's only 3. Let's try it again, just to make sure. So nozzle, let's remove that. Okay, so it looks like it worked. Let's go here, right? And let's refresh to see, make sure that this is 2. There we go, perfect. So it is working, all right? Okay, how about updating modules? So updating modules, the way we're going to implement that is that we're going to first retrieve the course. We know the primary key of the course that we want to manipulate or update. Once we have it in memory, that course has modules in there, right? And we can find that module, that particular module by its primary key. So there's a function that Mongoose has that allows you to search for elements inside child arrays by its primary key, and then it gives you a reference to that particular module. Now we're going to pass in the module updates, the changes we want to make on that module. Maybe we want to rename it, or the description or whatnot, right? And so we're going to assign and replace, make changes to the fields of the module that we want to modify. Once we have that, we can then save it back into the database, right? And then store it back into the database, right? Okay, so let's do that. In the update module, again, same thing, because modules were initially stored in a separate collection, right, in its own array. We could remove the module just by its primary key. But because now modules live inside a parent course, we also need the ID of the parent because we are going to use it to first retrieve the module by its primary key. Then within the course, within the modules, we can ask to find that specific module by its primary key because it's an embedded schema, and it gives us a reference to that specific module. Once we have the module, we can assign, right, and replace the fields that have changed, right? So we're going to apply the module updates onto the module. It is going to manipulate or update those fields that have changed. And then we can tell the whole object course just to save the changes back to the database, okay? All right, so let's do that. We'll add the new course ID and then use this save, right, to update the module, okay? So an update module in the DAO. So update module here, we'll need the course ID as well. And we'll just replace that. There we go, like that. And we'll need to make this async. There we go, like that. So we'll first have to retrieve that specific course from the database, make changes, and then save the whole course back to the database, all right? For the routes, we'll also we'll have to make a couple of changes, right? In the update module, we'll have to be async await. We'll need the course ID that's going to be passed in like that. Async await, and in the put, we'll need to encode the courses in there, right? All right, let's see, anything else? Course ID, all right. Now in the client, right, we were not sending the course ID to the server, again, because the server didn't need it, right? But this time around, we do need it. So let's add that as well. In the client code, right? Let's see, in the client code where we do the update module, we're going to pass in course ID. Right? And we're going to use the course API to encode the course ID, and the ID is in the module object. Right? So that means that in the page where we do the updates now, we do have to now pass the CID as a string. All right. All right, so let's try out, see if this blows up. Let's refresh. Let's log in again. Let's go here and change the fuel and combustion, right, to be, let's say, 102. The change, it goes out to the server, right, and there it is. So it went out. So let's see in the database if actually changed. So let's refresh, and the second one should be, there it is, fuel and combustion 102. Perfect. All right, so let's talk about implementing many-to-many. So many-to-many means that you have lots of instances of one type of a collection of objects, of instances, that are related to many instances of another type of object, right? In our particular case, right, our use case is that we have many users that are related to many courses, right? But also, you can see it as in, one user is related to many courses, and vice versa. One course is related to many users. And you can take a look at this as if for a bidirectional relationship, right? That if you give me the user, I can tell you what courses is that user enrolled in, right? And vice versa. If you give me the course, I can tell you, which users are enrolled in that course. As always, there's several ways of implementing this, depending on what type of database or of what type of format you are encoding this, if it's JSON or XML, or if you're encoding this in a relational database, right, or non-relational database, or if this is a class, an object-oriented programming language. Now, in relational database, the classical way of implementing many-to-many relationship is to have an intermediate table, right, or collection that it's basically two one-to-many relationships. So the classical way of implementing many-to-many in a relational database is to declare an additional table, right, that contains references to the records, right, that are related to one another. So for instance, you would have a new enrollments table, right, that would contain two foreign keys that reference the primary keys of each one of the courses and users that are related to one another. And so concretely, you would have a new table that would have its own primary key, right? And then we have two foreign keys like user ID and course ID, right, that reference the primary keys of each one of the users or courses table. Right now, this is something that obviously is the only way to implement this in a relational database. Now, in a non-relational database, there are a couple other ways to implement it, but we are going to follow the same strategy of a relational database, right? Using this intermediate collection that will have foreign keys to either instance. Okay? All right, so let's implement the many enrollments. So if you remember, right, we had declared courses and users, right, in respective models files, right? And we had chosen unique names for each one. For courses, we chose course model, and for users, right, under the users model, we chose user model. And we had said that that they weren't very consequential, right? And if you were just considering each collection individually, then the name was not very consequential. But now that they are going to be related somehow, now the name is very important. Okay, these names have to be unique, and they're going to be used so that we can establish relationship between these two collections. And so the way we're going to do that is we're going to create a brand new schema called the enrollments schema that is going to define two fields that are going to play the role of the foreign keys, right? They're going to be of type string because those are the values that are going to be stored here. This is the same type as the primary keys, right, of the schemas of each one of the course and the user model. And then we're going to have a field in there, which is a ref field, which says that this is a reference to a course model or it's a reference to a user model, saying that establishing that the ID that is stored here is actually referring to the primary key of whatever schema was used to define that particular model, right? And that's going to allow us to use that primary key in operations that look very much like a join, just like when you join in a in a relational database where you join the primary key with a foreign key, right, to join two tables. Similarly, here we're going to be able to do something like that. Even though that's not quite right, there's no such thing as a join in a non-relational database, but it's going to have the same outcome, right, as a join, even though we're not going to call it a join. Right? So let's create the schema for this enrollment. So let's see. We're going on the enrollment, and we are going to declare a new schema file. So schema, there it is. So I'll copy that. There you go. Right. So we have certainly fields that are specific to the enrollments, the status and whether you enrolled, dropped it, completed, whatnot, right? The final grade, the letter grade, the enrollment date. But then here you have these are the foreign keys that are going to contain the primary key values, right, of the specific course and the specific user that are in the enrollment relationship. Okay? So once we have that, we can create a brand new model file for our enrollment. And it looks very much like any other model. Say model that. All right. And then we're going to have a DAO that is going to declare several functions that will allow us to manipulate the enrollment. Right? Obviously, all of them are going to be written in terms of the low-level model. Right? So we're going to load the model, and we have functions that use the find to retrieve, or are going to use create to insert, right? Or they're going to use delete to remove. So always using the low-level implementations to implement the various operations. So for instance, we would like to be able to, for instance, retrieve all the courses for a user, right? That this is the operation that would allow us to populate the dashboard, right? If we log in, if we know the user ID, we could use the enrollment, right, to retrieve all the enrollments for that specific user. Okay, and the or if the inverse, right? If you navigate to the people table instead of a course, we would like to retrieve all the users in that course. If you give the ID of the course, we can retrieve all the users. So if you give the course, we can retrieve all the enrollments for that course, right? And then we would like to be able to enroll a user. That would mean that we would need to insert a new record into the enrollment table with the foreign keys of that reference the user and course that are related to one another. Or if you are an enroll, then we're going to remove the particular enrollment, right? So that you no longer are enrolled in that course. Okay. So let's implement each one of these, and then we can chat about it. Let's see the DAO for the enrollment. I'm just going to paste it here. And then we have find user for course. And we have enroll user in course. And we have the unenroll user from course. So those are the 4 basic operations, right? The first 2 are read operations that, given the user, I want the courses. If I give you the course, you give me the users, right? And the other 2 are for either creating the relationship or removing the relationship. Let's talk about the finders here, the read operations, because those are pretty interesting. So here we have the model.find. So model is the enrollment model that we just created, based on the enrollment schema that has the two foreign keys. And so here we are filtering. We're saying, okay, well, I want the enrollments. I want all the enrollments where I'm giving you the user ID. And what comes back is enrollment objects. So these are all the enrollments. But those enrollments are going to contain just what? Just primary keys, right? So this is just going to contain just this. It's going to contain the primary keys of the user and primary keys for the course, not the actual courses and not the actual users, plus the grade and all that stuff, right? Now, to populate the dashboard, right? I'm going to need more than just the ID of the course, right? I'm going to need the actual courses, and that's where populate comes in. Populate is the equivalent of a join. It says, hey, this is a foreign key. I mean, I already have some of the fields in the enrollment table or in the enrollment collection, but I also want to join, right? And I want to, and that's what join is in relational databases, right? When you join 2 tables, it means that you are retrieving fields from both tables. some fields from one table and another some fields from the other table, right? Where the primary key and foreign key match, okay? And that's where, this is where the matching happens, right? When you filter here, user ID, right, you're retrieving all the enrollments for that user ID. Now, the course ID, which you have here, right, you can then bring in the fields that you want from the course collection, right? And the way you do that is by using a populate. So .populate course means that, hey, this course contains a reference to something else, right? To a course. That means look up the primary key for that course, the corresponding course, and then replace the ID with the actual object, right, that's stored in the database for that ID. Right? So replace this with an actual instance. So now the enrollments contains all this information, right, the grade, the letter, blah, 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 all that status, and now the course object. Now in the dashboard, I don't really need the course. So what we're going to do here is we're just going to iterate over the enrollments, and we're just going to unwrap the enrollments, just retrieving the courses, right? Because that's what I'm asking here. Find courses for enrollment for user. So I'm just creating a new array, right, that only contains the courses, and that's what I'm going to return here. Make sense? Okay, so the inverse is also true, right? Find the users for course. Meaning if I go to the people table, right, the people page in a particular course, I know the course because I have it, in the params in the path, right? And the question is, well, I want to populate the table, the people table, right, for that particular course. That means that if I give you the course, I can go into the enrollments and retrieve all the enrollments that are the same course, right, which contain a whole bunch of users, right? And so now what that does is that it retrieves all these records, right, for the same course, a whole bunch of users, right, plus all this information. But I only really need the user information. So I do the same thing. I iterate over the enrollments, right, and just pick out each one of the users, create a new array of just plain users, and just return those users. Make sense? Okay, for the creation of the courses of the enrollments, right? We're the front end is going to send us the ID and of both the user and the course that we want to relate, right? And presumably, it's a student who is looking at all the courses and is clicking on the enrollment, right? Now the user ID could be taken from the current user, right? Because I'm logged in. You know the ID, my ID as a user, so we can use that for enrolling. And the course ID is perhaps the course that I clicked on in the user interface, and I can send you, I can post that to the server and pass you the ID of the course I want to enroll. And the enrollment would be to create a new instance, right, to insert a new, right, enrollment object into the database, setting the two foreign keys, right, of the user and the course, and then coming up with a unique identifier, right, that is the combination of user ID and course ID. And this would allow me to make sure that there's one user can only enroll in the course once, right? Because if the same user tries to enroll in the same course twice, then this ID would not be unique, right? And the database would fail it, right? Because the schema in the enrollment should be unique, right? So the type should be a string and should be required, and it should be unique. Okay. So that would make sure that a student cannot enroll in the same course twice, because the right combination of the user and course needs to be unique. Now to unenroll, right, it would mean that I would delete the enrollment, right, from that user combination of user and course. Okay. So we have the DAO. Now for the let's now taking a look at implementing some of these, right, with the corresponding routes. So first, let's do find courses for user, right? This is the query that we want to make, for instance, to populate the dashboard, right? we're going to provide you the user ID of the current person who's logged in, right? And we're going to retrieve the enrollments, right? And just pick out the courses. So that's what we implemented as the DAO. Now in the routes, right? We are currently using the DAO, the course DAO, that is using the array of enrollments. We don't want to use that anymore. Instead, we're going to use this new implementation of finding courses per user implemented in the enrollments DAO, right? As opposed to the course DAO that is using the old array of enrollments, right? So let's take a look at that. In the courses route, right, and the find courses for enrolled users, right now, right, we're using this implementation, which uses the array of enrollments. So it's kind of like doing the join, right, in memory, in the server, right, in the source code, as opposed to in the database. So instead, right, we're not going to do that. Right, we're going to use the enrollment DAO, which we have right here, and we'll use that instead. Right, we'll say we'll use the enrollment DAO, find courses for user, using the user ID. There we go. Now the user ID is either the ID that you're passing me from the user interface, or if you say current, that means that it's for the currently logged in person. So grab the ID from the person who's logged in. Right? Either way, whether it's me who's looking at my courses that I'm enrolled, or if I'm a system administrator and I'm looking at somebody else's courses that they are enrolled, right? So either way, it works. Right? So let's try that out. Okay. And so, for instance, if I log in again, okay, as Ada, and 1, 2, 3, there we go. So it goes to that same URL, right, and it responds exactly the same information with the courses. Now that query is populating, right, and by default it's it's including the modules again. So we would have to filter out and say that we only want certain fields and whatnot. But I'll let you do that. Now let's talk about cascade delete, right? And what we mean by that is that right now the enrollments is implementing a many-to-many, where you might have the enrollments table referencing several courses and referencing several users, right? So for instance, here we have in blue, we have 3 enrollments that are all referencing C3, course C3. And it says that user U2, 4, and 5, 2, 4, and 5 are all 3 enrolled in course 3. It also says that these yellow enrollments say that student U2 and U5 are both enrolled in course 1. And you can follow the arrows here. Now, what happens if I try to unenroll, right? So for instance, or I try to delete a course, right? So for instance, if I remove course C3, then these enrollments no longer make sense, right? That student U2, 4, and 5 would be enrolled in a phantom course. It doesn't exist anymore. So we need to be able to propagate this deletion, right, in a many-to-many, or even in one-to-many, where you remove on the one side, right, of a relationship, that one side needs to be propagated across to the records that are associated, right? So we would want to propagate the deletion of the course C3, propagate it to deletion of the corresponding enrollments, but not vice versa, right? If I remove a user, right, even though this is also on the one side of a one-to-many relationship, right, it doesn't mean that if I remove the user, I'm going to remove the enrollment, or and it just propagates to the course, right? It's always removing the relationship, right? If I remove a user, I would remove the enrollment. If I remove the course, I would remove the enrollments. But it doesn't mean that if I remove the course, it propagates to delete the user, or that if I remove the user, it propagates to delete the course. Only the relationship between the two would be removed. Right? And that's what we mean by cascade delete, right? That the deletion of an item, right, at least on the one side, it propagates or cascades to the many side, right, of the relationship. Now, this is, we can implement that by using, creating a function that, if to delete all the records, right, for where the course C3 is equal to that particular ID, and then boom, removes all the enrollments there. Okay? So let's take a look at that. So let's implement a unenroll all users from course. Okay? All right, so that means that this will remove all the enrollments for the particular course. Okay? So let's do that. So let's add that to our existing enrollment DAO. So in the enrollment DAO, let's add this new function. Oops. This, and let's add it to our return. There we go. And then now in the deletion of the course, right? What we're going to do is that we used to filter out the enrollments, right, from the quote unquote database. So we're not going to do that anymore, right? Instead, we are going to use this new function declared in the enrollments now, right, to remove these enrollment records from the database instead, right? So let's refactor that, right? In the courses DAO, in the delete course here, right? We were filtering out the enrollments and all that. We don't need any of that anymore, right? We're just going to remove the course, right? And instead, we're going to remove the enrollments when we remove this course. So when the route that deletes this course is also going to use the enrollment DAO to remove the enrollments for that particular course. Right? So yeah, so let's go to the route that we use for the deletion of the course. We're going to add this call to remove all the enrollments, right, for that particular course. Right. So let's do that, and that would be in the route for the course that deletes the course. So here's delete the course. Notice that we're only deleting the course, but we also need to remove the enrollments. So we have the enrollments now, right, that we have here, right? And then we can unenroll all those users, right, from the course. All right, so let's try that. Let's see if we try this out here. We let's see, let's refresh. And so, for instance, Ada is enrolled in 3 courses, right? So Ada 1 to 3, sign in. So she's enrolled in rocket propulsion, aerodynamics, and spacecraft design. And that's taken from the database enrollments here. So if you look at the enrollments at the bottom, we see that Ada is 777, right? And she's enrolled in RS 101, 102, and 103. And so, for instance, course 103 is this one over here. So he's 101, 102, 103. So it's spacecraft design. So let's remove spacecraft design. And once we remove that, it not only should the course disappear, but we should see that the enrollment, this enrollment record here should disappear as well. Right? Also, if anybody else is enrolled in 103, right? So, for instance, we might have, let's see, who else is enrolled in 103? I guess no one else. Okay, no one else, just her, right? So let's make sure that this is removed as well. All right, so if we go here and let's inspect to see if we get any errors here at work. I'm going to remove this. So let's say delete. Okay, it was removed. 103. Okay, acknowledge, delete. That's correct. So let's go to the courses and see. Okay, this should have been removed. Let's refresh. It's no longer there. Here, RS101, 102, 104. So 103 is indeed removed, but the enrollments also should have been removed. So this should be removed. Let's refresh. There were 12 enrollments. Refresh. Now there's only 11. And there it is, right? The enrollments for data has been removed correctly. Okay. All right. So on your own, implement the enrolling and unenrolling that you had implemented in using the server, right? So you move that implementation to the database, right? Here are just a few suggestions, right? That we are providing some implementation for enrolling user in course, right? Which we haven't used so far. Okay? So it's there implemented. So you're welcome to use this. Although if you have your own implementation for enrolling courses, users in courses, that's fine. Just feel free to use your implementation. But nevertheless, here are just a couple of suggestions, right? Creating new records into the enrollments table collection, and enrolling a user in a course, right? This is the a suggested route, right, where you can provide the ID of the user and the course that are going to be enrolled, right? And then inserts, right, that new record of enrollments in the database. Okay. Now in the client side, right, on the user interface, you can post a new enrollment, where you can provide the both IDs of the user and the course that are going to be enrolled, and that should create a new record in the enrollments table, right, of the user and the course that are now enrolled in. Okay, and unenroll obviously would remove it from there. Yeah, this is just more route for the for unenrolling, right? Where typically it would be the person who's currently logged in who is unenrolling from the course, right? Or it could be that a system administrator is unenrolling someone else, right? So if the ID comes in as current, then we're going to assume that you are the currently logged in user and you are enrolling yourself. But this is ready to also be used by a system administrator if you provide the ID of someone else. So me as a faculty, I can enroll or unenroll other people, right? Or they can enroll on their own. Okay. Same thing for unenrolling in the client, right? You can pass in the ID of both the ID and the course that are unenrolling. Okay. Also in the course people, this is the table, right, that shows the people that are enrolled in a course, right? Once you navigate to a course, if you go there, right, it should display all the users that are in that course. So again, this is a suggestion. Like on the server, you can use the find users per course, right, that we introduced earlier in the DAO. That if you give me the ID of the course, I can then return to you the users that are enrolled in that course, right? And this is on the client side, right? That we are creating using Axios to do a get, right, for retrieving the users in that course. Okay. Now, because this, if you need to know whether you're enrolled or not, right, and you need a cookie or using current user, then don't forget to convert this Axios into Axios with credentials. Okay? Only if you need it. All right.